people, Mars. Mars has tweaked our imagination for thousands of years. It's this little red dot that flies across the sky at night. We can see it, we know it moves. What do we know about it? How can we find out more about it? These are all the things that we're going to learn. So, Mars, you are members of Mission Control. You are all mission specialists for the day. The red planet.
It does have seasons like Earth. It's tilted the same, so the equator is warmer and the poles are colder. As far as we can tell, there's one thing that all life needs.
Water?
Water. You got it. Liquid water. We're in the Goldilocks zone. We're not too hot. We're not too cold. The water's not frozen. The water's not boiled into steam. So we got liquid water. So we have a wonder. We look up on Mars. Those people, like Sue said, they wondered, is there life on Mars? The sun hits Mars. There's sunlight. Is there life there? Is there a civilized life? You know, civilization, advanced life? Advanced intelligent life with technology that could build canals? Is there a life on another planet? Is there a life on the moon of Jupiter? Is there a life somewhere on a planet outside our solar system that goes around a different star? Somewhere there's lots of extrasolar planets that have been discovered. That's what we want to know. Are we alone? Are we the only life in the entire universe? Would you like to know that?
The Martian rover Curiosity and all its unbelievable instruments. Unbelievably, oh my gosh, as they say in the States. Cam. This is him. Curiosity is an American exploration rover destined to the study of the Martian soil. So yeah, another one, you're going to say. But this one, be careful, he'll blow your mind so much, well, you'll see. It's the Cadillac of all rovers. A big high-tech baby of 800 kilos and 2 meters long, with a nuclear battery, 10 scientific instruments, and 30 engines. The first time it is used for space exploration. Then, the measures are sent to Earth and analyzed by scientists. If the stone is interesting, our super rover will drill the rock with its robotic arm and analyze it in situ. Today, there is no water in the liquid state, but the traces are still there, close to old canyons or riverbeds, in rock such as volcanic or sedimentary rock, like basalt or granite. So, it is this type of rock which will be the preferred aim of our Curiosity rover. Because it is not life that scientists are looking for, but simply if it was once possible. And don't forget, no water, no life.
Back in November, this rocket blasted off from Earth. Okay? It made an orbit. Then the second stage continued on to Mars. And this took 8 months to get where it's going. And when it gets closer to Mars, it's going to enter into an orbit. And pictures are going to be taken of the surface so they can verify where they want to land. Okay? This is just the second stage. The lander is going to come out of this. This is going to split. There's an actual landing disc, if you want to call it, that will go into the atmosphere, and it will slow from heating, just like the Apollo spacecraft. And at the last minute, it's going to come apart, and the rest of it is going to come down with the actual rover, and it's going to come and it's going to hover and drop the rover on a rope. Here, you gotta pull on it a little bit. Ready? Lower the rover. This is the sky crane. Is that cool? Okay, now. The rover flies away and crashes over here. And we have our rover.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we are facing, and one that we have never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it will only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity. Getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of the crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage, it's a collision course with the rover. We must cut the bridle immediately and fly to the descent stage to a safe distance from the rover.
Can go to those rocks and gradually climb up the mountain and look at the rocks from the bottom, which would be the oldest rocks, all the way up, and get a picture of how the conditions have been changing on Mars and whether or not, from the data, whether or not conditions were favorable for life at any of those stages. Okay? So this is the area where we want to be. Okay? We want to find lots of rocks, right? Because that's where the information is. All right, so this is Gale Crater, and this is the mountain inside the crater. So let's blow it up. to here, and this is inside the crater. Where do you want to land?
I think we should land more.
Okay, you want to land over here somewhere? All right, let's blow it up, this area, and there's, okay, this is this, okay?
Probably land here.
Where do you want to land?
Oh, it's you don't land on the box.
Yeah?
We decided that we should land where the rocks are because that's the history, and we decided that you should land here.
We know what they want to see. We have to make it possible for them to get there and see it.
I'm not happy with it because you have to find a flat land, because if it's all bumpy, you can't really land it, right?
Well, I guess we're going, where should we land them?
Where it's like something like flat, like
Back to the drawing board.
Ah,
Should go. They should land on the floor.
They should
apparently, yeah.
like here.
So you're right, this is the
You're very high, but you're high above this
Is there
area.
really a group line?
No, that's just to tell you, that's just to orient the
You know what?
All right.
Rover operations, where science team is happy, they're gonna get their information. Mission control is happy. Now it's up to you to make it happen.
You are going to see what you're doing through this camera. Now you're heading through to this crater. You want to drive up to the crater and you want to explore the other side here. Okay? That's it.
Okay, mission control and the science team, we know where they want to go.
All right, did it get any fossils?
So it's going to zap it with the laser. You're going to bring them back for analysis.
Bring the samples back to Earth.
Straight ahead. Now we have to go back into the laboratory.
That's not a beetle.
Wow.
She has a beetle. No. That's a beetle, Gabby.
Thank you, science team, you did a great job. Mars Rover team, Rover Ops, thank you, you did an absolutely fantastic job getting specimens for us. Science team, mission control, you did a great job of finding the perfect place to land. Did everybody have a good time? Thank you very much.